Now we're going to look at gas evolution reactions. So in these kind of reactions, we have two aqueous solutions that we mix together, and instead of seeing a solid form, we get a gas product. So that's going to bubble out of solution. It's going to appear as bubbles or fizzing. Some reactions form that gas directly from the ion exchange. If we mix potassium sulfide and sulfuric acid and we just swap the ions, we get dihydrogen sulfide, which is a gas, and that will bubble out and smell really, really nasty, like rotten eggs. Other times, the reaction forms a gas because one of the ion exchange products actually is unstable and decomposes. So here, sodium hydrogen carbonate and hydrochloric acid, that's baking soda, will make sodium chloride and carbonic acid, but carbonic acid isn't stable. And so it will decompose into water and carbon dioxide, and you'll see those little bubbles forming. So here's an illustration of that, mixing sodium hydrogen carbonate and hydrochloric acid, and you'll see this fizzing, a lot like, if you drop Alka-Seltzer in a glass of water. So what happens is that the CO2 that is formed here, being a gas, will form little bubbles, and those will rise to the surface and pop. So these are the gas evolution reactions that you need to be aware of. The first one we talked about is just if you get the product H2S, that's a gas. The other three types here have unstable intermediates. So carbonic acid, just looked at that one, sulfurous acid, or ammonium hydroxide. When these guys fall apart, or when they decompose, they at least do so in a nice pattern. So H2CO3. This is going to decompose to form one water molecule. All of them do that. And to figure out the identity of the gas, we're just going to look at, if we take the two hydrogens and one of those oxygens away, what do we have left? CO2. That's our gas. If you swap ions and you get sulfurous acid, that's unstable. It's going to come apart, decompose into water, and take off the two hydrogens, take off one of the oxygens, SO2 gas. Ammonium hydroxide. Will also decompose and form water and a gas. So I'm going to get rid of two of the hydrogens, that one and one of those, and get rid of the oxygen for the water. And the remaining thing is NH3 ammonia, which is the gas. There definitely could be a question on an exam that you would need to remember which of these form gases upon decomposition. This is not a big deal, okay? It's not working. So write a molecular equation for the gas evolution reaction that occurs when you mix aqueous hydrobromic acid and aqueous potassium sulfite. Now we got a big clue here because it says this it's a gas evolution reaction. So we're going to write the formulas for the two reactants, and those guys are hydrobromic acid and potassium sulfite. So hydrobromic acid, does that acid have oxygen in it? No. The ones that start with hydro are binary acids. They're hydrogen and one other thing. So here it's hydrogen and bromine. and that's going to be aqueous. And we would identify how many hydrogens there are by looking at, well, what charge does bromine form, or what charge does it have when it becomes an ion? It's -1. And so then we just need one hydrogen ion to make this neutral acid formula. Then over here we have potassium sulfite. Potassium is a metal, so we should recognize this as an ionic compound. Potassium has a +1 charge. And then what's the formula for sulfite ion? Sulfate is SO4, and so sulfite is the light version, it's SO3. Still with the 2- charge. So then from these charges, we see that the formula for that must be K2SO3. That's also aqueous. And so then we're just going to swap partners, which is the general approach to predicting products for reactions. So we'll put potassium and bromide together. So that's going to give us KBr. That's going to be aqueous because all potassium compounds are soluble. You can use the solubility rules if you need to. And then we've got H plus and SO3, 2-. So this 2- charge tells me I need 2 hydrogens, so this is going to be H2SO3. That's an acid. That's aqueous. Is this equation balanced? No. What do we need to do? Yeah, we need a 2 of the KBr because we have 2 potassiums here. So 2 KBr. And then that makes us need a 2 over here on the HBr. And that works out well because 2 hydrogens, and we've got 2 hydrogens over there. Any questions so far? We're not done yet. So we predicted products, but the problem told us that this was a gas evolution reaction, and we don't have any gases yet. This is the one that's going to decompose and form a gas. So it's going to decompose by losing a water molecule, and then whatever's left of it is the gas. And so this guy will turn into 2 hydrogen ions and SO2, which is the gas. So the full equation is 2HBr plus K2SO3. It's going to form 2KBr aqueous. Yeah. You see what I did there? That was wrong. What's wrong with this? It's supposed to be H2O. I know, I'm so sorry. I really try not to do things like that. I was just, taking it apart like it was ions. This decomposes and forms water and a gas. And so H2O, which is a liquid. There we go. So look at H2O and SO2 gas. Any questions?